Okay, we have started the bear hunt activity, and we in this activity are going to pretend like you are in the Northwest Wildlife Preservation Society, or you are a ranger in the Northwest Wildlife Preserve, and so you have to count the number of bears that you have in your area. So you'll count the number in 1 square mile, and then you'll go multiply that for your whole entire forest of 100 square miles or whatever it is. But we're going to be working on counting our bears. So we had our M&M packages. The M&Ms are the bears. And the only M&Ms we're going to be interested in are the orange, green, yellow, and brown. So what you've done is you've gone and you've put your individual amounts, and then you put your percentages in here. So you counted your personal percentage amounts of orange, yellow, green, and brown. And then we collected data as a class, and this was our data for our class. So we had 32.14% of orange, 24.39% of yellow, 26.42% of green, and 18.56% of brown. Okay, so then we put that information here for our class's performance. And then we went outside and we did a lab to collect data. So I went and I took all of the bears up, I took all of the M&Ms up, I put them out on the ground, and then we went and we collected data for how many bears. And so you would go through and you would count the number of bears you saw that were orange and yellow and green, and so you would count how many you saw in the grass of these particular M&Ms, and then you got your individual tally total and percentages, and we're going to use that to get our experimental percentages for the whole class and compare them to what they should be. Okay, so we're about to collect our data for the experiment. This is the actual. Okay, so let's go ahead and compare our experimental data to what we know that we actually calculated whenever we did our original calculations. Now the interesting thing is that we're going to probably be even closer than we should because we've got averages of averages going on. And that's what happens later in Chapter 18. We see that when you get averages of averages, you get more accurate. So our experiment is going to be a little more accurate than it probably should be because we're getting averages of averages here in our data. But when we did this as a class, our class ones were 32.14. Okay, so that's pretty close. So our experimental was pretty close to our actual. For our yellow, our class was 24.39. Okay, so this is more, 4 points more than our actual. So here, okay. And so then for our green, when we did it, our actual data for green is 26.42. So we saw a little bit more green. But the significant difference is the actual data says that we actually are supposed to have 18.56% brown. But when we calculated it, we had 11, or when we did our experiment, we had 11.46. I would consider this a significant difference because that's 7 whole percentage points difference. So our question is, yes, how did your outside bear hunt compare to the expected probabilities? So how did our outside bear hunt compare? Not bad. You know what? That's true. I would say that for orange, yellow, and green, y'all actually weren't too bad. When I did this experiment this summer, we were even way off on the green. We didn't see very many green ones either. So what could I write there? Okay, good. Very good. So we could say for orange, yellow, and green, our experiment was close to actual data. Brown, the brown experimental numbers were very low. Okay? So what happened in Y? Well, that's kind of redundant. What our brown experimentals, our brown numbers were low. So our brown numbers were low. Why? Because why? Well, what is wrong with you people? Are you colorblind or what? You didn't see brown bears. Why? Ah, okay. They proved to be what? The most evasive of our sight. I don't know. Okay. Couldn't see them in the grass or in the dirt or, you know, whatever. They were camouflaged, yes. Isn't that our thing on Friday? Okay. Compare the term, okay, so here we go. So they were camouflaged and we couldn't see them. Oh, man, that went away. But now let's talk about this. Compare the term population with sample of the population. Okay, so you may even want to reference your vocabulary that we just got. So find population Okay, so our population was what? Good. Is the entire group to be studied? Okay, and then sample of the population, what's that? Good. So that's the part of the population actually examined. Okay, so talk to me about this. You're a park ranger. You were flying over the forest. Tell me what you did. Okay, so Brian's saying he passed over the lake. There were a lot of bears. He had clear view, so maybe his data was more accurate. But tell me, when we did our experiment, what were we dealing with? The entire population or our sample of the population? We were dealing with a sample. You made one pass over the forest. So you went over the forest, made one pass over the forest, and then then you would assume that that's the whole percentages for the entire forest. Okay, so we were dealing with a portion of it, not the entire population. Is it realistic to expect that whenever we do experiments, whenever we conduct surveys, that we can do them for the entire population? If we wanted to, find out how many people, or the percentage of people that like blue over green, how are we going to do that? Are we going to do that with a sample, or are we going to do it with the population of the entire United States? Okay, exactly. So in statistics, we're going to have to understand how to deal with the sample aspect, how to become more accurate with the sample aspect, how to design experiments, knowing that all we're collecting is sample data. Okay? Now, I asked you earlier, I said, hello, are you colorblind or what? Whenever we had our information, there's actually a vocabulary term that I just remembered. I should have stuck that in there. What happened and why? I want you to add this here. We couldn't see the brown bears. We were visually biased. That would be the statistical way to say that. We were visually impaired or visually biased because we couldn't see, to no fault of our own. And in an experiment, you may not, you have to make sure that you design an experiment so bias doesn't happen. Because if you have bias, then it's going to ruin your results. And it's stupid to even begin because you can't, it's just going to do you no good. So you have to make sure that when you are doing experiments, you are avoiding bias at all costs. Okay? All right, let's go ahead and go on to the last question. How large does your sample size need to be in order to get a valid sampling result? What do you think? The larger the better. Okay, good. The larger the better, the more accurate. Okay, so you can put that in there. But I'll tell you that we are going to spend time doing this. The larger the better. So that, at this point in the course, that's all you know. But throughout the course, we're going to work towards coming up with an understanding of how large it actually needs to be to come up with the concept that you can feel confident that your data is representative of the entire population, even though you only took a sample. Okay? So throughout the course, we'll get into the specifics of how many you really need to take to feel that you represent the entire population. Okay? All right.